In this video, we discuss one of the design tools used by programmers called pseudocode. The word pseudocode means fake, so pseudocode is fake code. It is an informal language that has no formal syntax rules, and it is not meant to be compiled or executed. Instead, the programmers use pseudocode to create models or mock-ups of programs. Because programmers don't have to worry about the syntactical errors while writing their pseudocode, they can focus all their attention on programs design, on the actual program's design. And you'll find more information about that in your textbook, starting out with Python by Tony Gaddis, page 61, 6th edition, or it may be different pages if you're using 4th, 5th, or 4th or 5th editions. Pseudocode is more like an algorithmic representation of the code involved. And what we mean by algorithm is a step-by-step method to outline the steps to solve a problem. We use English-like sentences to represent the code involved. This means when a code is expected to be formulated, it cannot be directly drafted. The code will need to be first generated into a Python pseudocode, and then it needs to be formulated into an actual code such as Python or C# or C++ or JavaScript or any of the other high-level language programs. And then it needs to be formulated into that actual code, as I said earlier. This process of formulating an English sentence-like algorithmic representation is what pseudocode Python pseudocode means. In simple terms, it is a syntax-free representation of code, so it does not involve any code at all. It must be a very close representation of the algorithmic logic. It must be such that each line of the Python pseudocode can proportionally be translated to the actual code. For non-technical participants, it facilitates speedy code resolution. These are key advantages of using the Python pseudocode in programming. So basically, you must write this Python pseudocode line by line, representing each involved sentence as a single line. Number 2, just as you use indentions in Python code, you should also prefer indentions in Python pseudocode. Ensure that each statement of the pseudocode is simple and easy to understand. Make sure the pseudocode's first word is always in uppercase or either the first letter is in uppercase. Ensure to use periods and delimiters wherever needed. Okay, let's look at some examples. Problem 1. Ask the user to enter their name, course expectations, and their dream job once they complete their degree and display this data. Or in this way, we could say data or information because it's data in one instance and it's information in another, depending on how it's being used and if it's being reused. Input your name. That's the pseudocode. Input your expectations of this course. Input your dream job once you've finished your computer science or IT degree. Display your name. Display your expectations of this course. Display your computer science, engineering, or IT dream job. This is an example of pseudocode. Problem number 2, calculate the gross pay of an employee. Here's the pseudocode. We're going to input the employee's name, input the hours worked by the employee, input their hourly rate, pay rate, calculate the gross pay. That is, we're going to multiply the hourly pay rate times the hours worked by that employee. Display the employee's name, display the hours worked by the employee, display the employee's pay rate, and display the employee's gross pay. Okay, let's put the S here. Somehow it went somewhere else. Times. Okay, so let's look. This is the outline that we're going to follow. So let's see what it looks like when we convert this to Python. This is merely the pseudocode. Using this pseudocode, Let's see what it's going to look like in Python code. Don't forget to put in your comments. They are just as important as code. In all my programs, I want you to write your name, put down a label, programmer, date written, program name, purpose. Begin the main gross pay program. I'm going to start distinguishing between the main program and whether or not we have a sub-program. Later on, this is going to be important, so let's just form the habit of writing out main program at this point. So after we initialize the variables used to store calculations, in other words, this is not a variable that we are entering. It's a variable that's going to store the hours worked and the pay rate, and it's going to be stored in an empty variable. So we want to make sure that in the memory of the computer, that if there was anything there, we're going to erase it and put 0 there so that when the calculations do come up, they will be accurate. Next, here are input operations. We have 3 input operations. If you look at the actual pseudocode, we are following the pseudocode, exactly what it says. Input the employee's name. That's what we're doing here, saying name is equal to input employee's name. That's string data. If you don't tell the computer if it's anything other than a string, the input function automatically allows you to enter string data. Hours worked equal to float, input how many hours did, and I'm going to do something a little different. I did, and then I want the name to be in there, work. Okay, and then input their hourly rate. I want to personalize the statement by adding their name, and that's what I'm doing. I'm also using the F string so it will display it in a particular manner. So let's take a look at that. Float, input, F string, how many hours did, and then I put in the name so that shows up, and work. I put a space between that so that the variable name and the string literal, when it displays, does not run together. So for the input statements, we have the name is equal to input the employee's name. Hours worked float is how many hours did, and I used the F string. You can use that inside of your input statement because it allows us to display data, and we can specify how we want that data to be displayed using that format string. And then input what is, you have to be careful about putting single quotes in the F string. So I took it out of that and said what is, and then name, whatever that name is. It's not enclosed in quotes. Plus, I'm concatenating these things together. Double quote, the apostrophe and S, current pay rate. So these are the input statements. Now that we've put in our input statements, 1, 2, 3, we calculate the gross pay, multiply the hours, the hourly pay rate times the hours worked. That's what that shows up. So if you were to look at that, that's what that means. Hourly pay rate times the hours worked by the employee. Finally, we will display the output, and we call this output operations. Note all of the comments. These are important. Line 22 gives us display 2 blank lines. We make a horizontal set of dashes here to kind of format our report in a particular manner. And at line 24, we're going to write out the employee report label. Another line, horizontal line, 50 little dashes. Now what we're going to do here differently is, because we have employee name, that is one string literal, plus another string together, we're combining it, concatenating it, and then we're creating a new one variable string so that it makes it easier to center it in the report. So that displays the employee's name. And next we're going to display the hours worked, display the employee's pay rate, and display the employee's gross pay. Okay, so all we're doing here that looks real complicated and convoluted is that because there is more than one field or object that we want to display on a line, we can take it and store all of this in one variable name, and then reference it and making it easier to center. Likewise, with the hours works plus, we're going to use that format function, which says format, what you're going to format, how it's going to be formatted. We'll take all that and store that as one variable, and then we can go in and say, let us center this, even though there's more than one object or one field per line. Likewise, the pay rate, we're doing the same thing. Now, 6.2F is a format specifier. What this means is that I'm going to tell the computer to allocate up to 6 places, which includes the decimal point, 2 places to the right of the decimal, 3 places to the left of the decimal plus the decimal. Thus, we have 6.2. And you also have to specify what kind of data you're formatting, and that is F, which is float. We're doing the same thing for at lines 30. Format pay rate, comma 10, comma 0.2F. And then we give it its own name so that it's easier for us to center that. This isn't the only way to center. This is one easier way to center. Okay. And then the gross pay, we're doing the same. We're following the same type of layout. So if you look at line 34, F string and then print GP and then we center. Makes it so much easier. So let's run the program. Run. So let's just put an arbitrary name in. Mary Bradley. She worked 40 hours and she made $175.37 per hour. That's her pay, our hourly pay rate. And see, it displayed those dashed lines, employee report, employee name, Mary Bradley, hours worked, pay rate, gross pay. And then, of course, you see how all the values align correctly because they are using a similar format, and plus we centered our data. Feel free to view this program as often as necessary. There is a sample handout under the pseudocodes, so please look at that and go over it as often as necessary.